Okay, let us continue our discussion, lectures on metaphysics. In the previous session, we talked about the four-category ontology. We explained what we mean generally by these categories, and we claimed that these four categories of kinds, objects, modes, and properties, and the formal ontological relations that exist between them, characterization, instantiation, and exemplification, they are necessary and sufficient to understand the inventory of things that exist in the real world. And in the upcoming lectures, we will go into more details. We'll look at each category in more detail and try to see why it is that we think they are necessary and sufficient, where they come to help us in our metaphysics, and what we would lose if we put aside any of these categories. Okay, so we will begin by looking into the particular things. So if you remember, we first started dividing everything into universal and particular. The universals were the ones that had instances like kinds and properties and relations, and objects and modes were particulars. Those were things that did not have any other particular as their instance. So today we will look into objects and modes as particular things that exist. Starting with objects, because this is the most common thing that we know in our ontology and we understand in our everyday life. To understand the question of objects, one of the interesting concepts very related to the concept of objects is of enumeration. It's about counting things. Suppose that I show you this image, or I put everything that's in the image in front of you, and I ask, how many objects do we have here? And I'm asking for a number, right? How many objects do we have? Now, if you think about it, you might immediately say 5, but if you say 5, you're basically saying that we have 5 books here. But if you think about it, it's not really clear how to answer this question unless we know exactly what it is that we are counting. Are we counting the number of books? Are we counting the number of pages? Are we counting the number of atoms? What is it that, or are we counting the number of images that I'm showing here? What is it that we're trying to count here? So let's suppose that you say it's 5. And then someone else comes along and says, actually there are 10 books here. And they say, okay, how do you count that it's 10? He says, okay, like 1, 2, 3, 4, 5, and then it goes, okay, 6, 7, 8, 9, 10. But then you tell them, but you're counting the same book twice. So the idea is that if we want to be able to count something, we need to have two things clear. One is what kind of objects we're counting, because that will define exactly what it is that we're counting. And also we have to make sure that we're not counting twice. So if I'm counting a book there, I wouldn't count it again, because then I would be counting multiple things, but it's not actually multiple things. There we're talking about the same object. So we're starting from counting, right? We're saying, okay, what kind of objects we're counting, and we need to make sure that we're not counting twice. Now, these questions are captured in the idea of identity. So when we have an object, basically, what we need is an identity condition. An identity condition will tell us what it is that we're counting. When do we count something as one? So, for instance, when we say a book, the identity condition of books will tell you what it is that you need to count as one unit. So you wouldn't count each page, for instance, as one book. You will count the all pages with the covers and everything else as one book. And that's determined by the identity of the book, the identity condition of the book. The identity condition also tells us that it basically tells us to make sure not to count the same thing twice. it provides a condition at which we can claim that two things are identical, so we don't have to count them twice. So again, the identity condition of these books help us to answer the question that there are 5 books here and not, for instance, 6, because you're counting the same book twice. To be able to say that you are counting the same book twice, you need to know that you're counting the same book, which means that you need to understand the identity condition of a book. So through this idea of counting, we realize that the identity condition is crucial. It's something necessary for objects. We actually can define objects based on identity condition. We define objects as particulars that have determinate identity condition. And this identity condition, as we just saw, is determined by their kind. What kind of thing are we talking about? If we're talking about a book, that's one thing. Then we will have, for instance, 5 books. But if you're talking about a page, that's a different kind of thing. And of course, it has a different identity condition. And then we wouldn't say we have 5 pages here because we have more than 5 pages here. So that's the idea that we have about objects. Objects are particulars that have determinate identity condition. Now note that these identity conditions, they don't not only help for synchronic identity, but also diachronic identity, which we can also call persistent conditions. Synchronic means that on this moment at the same time. Diachronic means through time. So another part of this counting is that if you get one of those books, and let's say you open up that book, you wouldn't have a new book. You would still say it's the same book, I just opened it. But imagine that you had a statue of a book, and then you got that statue and then you opened it from the middle. Then someone would claim that you destroyed that statue. So why is it that for the book, when we open it, we say that it's the same book, but for the statue, when we open it, we say that we destroyed the statue. It goes back to the identity condition of the thing, but now we're talking about diachronic identity condition or persistent conditions. Under what condition does that thing can remain the same thing while it's changing? And a book is a kind of thing that you can open it and you can read it, and it's the same book. But a statue is something that when you open it, you're basically destroying it. So again, this is talking about identity condition, and it says that the identity condition depends on the kind of thing that we are dealing with. In other words, the kind of thing that we are dealing with will define the identity condition of that object. So again, as I explained, if we open the book, it's the same book. Why? Because that's just what books are. The kind of thing that we're talking about, the book, provides this sort of identity condition that we can open them and read them. Now, identity is, as I said, so it's an ontological relation. It's a formal ontological relation when we have between two things. We say two things are identical to each other, and we can get to that conclusion based on the identity condition of that thing, and that identity condition is dictated by the kind of thing that we are dealing with. There's a very interesting, very useful law for identities, which is almost very trivial, but it's very useful, something that is known as the Leibniz law, which talks about the indiscernibility of identicals. It says that if you have two things, X and Y, who are identical to each other, then we can define a necessary condition. If two things are identical, then anything that is true of F will be true of Y, and vice versa. If you can predicate anything of X, if there's any proposition that's true of X, it will also be true of Y. So for instance, let's suppose that I say X is this book that I'm showing you the picture, and Y is this complete Sherlock Holmes book. So the Sherlock Holmes book in front of you, that's Y. And this book that I'm showing you is X. Now we see that I'm talking about the same book, right? So we see a posteriori that the book that I'm showing you right now is the complete Sherlock Holmes, as we can read on the cover. So we see that, and we're assuming that X is identical to Y. Now it follows from Leibniz law that if anything is true from this book, then it's true from the same book. If X has a stain on page 24, then Y would also have a stain on page 24. Which is, again, trivial, right? We're talking about the same book. So if this book has a stain on page 24, then the same book will have a stain on page 24. It's impossible, for instance, that Y, this complete Sherlock Holmes book that we see, has a word that this book that we see in front of us does not have, because they're basically the same book. Now, of course, in this direction, it's so trivial that we're just thinking, okay, how is this going to help us in any way? But the good thing about this law is that it provides us with a necessary condition for identity. It basically tells us that if you have an X and if you have a Y, and there is something true of X that is not true of Y, then those two are not identical to each other. So if I tell you that I have two books, X and Y, but one of them is one page longer than the other one, then you can be sure that X and Y are not identical books. They're not. We're not talking about one book. We're talking about two different books. And we see in a moment how this is going to help us identifying things. So we're still talking about objects, and one of the interesting examples in ontology is a statue made out of something, bronze or a lump of clay. So let's look at this example. We can all agree that there are two things here. One, there is a statue of Albert Einstein. We can see it here. And two, there's a lump of clay here. These two things exist. There is the statue, X, and there is a lump of clay, Y. Now the question is X identical to Y? And the answer is no. And the way that we can show that they're not identical is, let's suppose that you smash this statue, not in the way that I'm showing in the picture, that's completely destroying the lump of clay. What I mean is just press it down. Press it down until the statue is completely deformed. Now, if we do that, then the lump of clay is still there. But the statue is not there. The statue is destroyed. I just pressed it down and I flattened the whole lump. And note, why is that? Why is it that when I crush this thing down, one of them still exists, but the other one does not? This goes back to the diachronic identity condition of different kinds of things. And a lump of clay, if you have a lump of clay and you're playing with it, it's still the same lump of clay, in the same sense that if you have a book and you open it, it's still the same book. But if you have a statue and you open it, or if you have a statue and you press it and deform it, then you basically destroy the statue. So the lump of clay and the statue, they have different diachronic identity condition dictated by the kind of things that they are, which basically means that if you do that deformation, one of them still exists, that's the lump of clay, but X does not exist, the statue goes out of existence. But that means that Y survived this smash, but X did not survive this smash. There's something true of Y that is not true of X. And by Leibniz law, we can say that X is not identical to Y. Or the other way around, if we go inside the statue and let's remove a small piece of that clay, we have a different lump. because a lump of clay is just this continuous mass of matter. If you pluck something out of it, then you have a new lump. You will still have a lump of matter, but it's a new lump. It's not the previous one because you pulled something out of it. So if you change, like imagine that you go inside that statue and then you remove a piece from within the mass and then you fill it in with some new clay. The statue is the same thing and nothing changes for the statue, but the clay is different. So again, we're going through a transformation that a statue can survive. Again, like a book, when you open it, it's the same book. If you have a statue and then you remove like a 1 millimeter diameter sphere from the inside of the statue is still there, but the lump of clay is not. So through that change, Y does not exist anymore, the lump of clay, but the statue is still there. So again, X persisted through the change, but Y did not persist through the change. Therefore, X and Y are not identical to each other by Leibniz law. So what we are saying basically is that if someone claims that X is identical to Y, they are making a category error, because we are talking about different kinds of things. And we know that we're talking about different kinds of things because kinds dictate the identity condition of the instances of that kind. And since we can see that these two things have different identity conditions and different persistent conditions, they're coming from different kinds. And two things from two different kinds can never be identical from each other by Leibniz law. So what happens if we don't, if we're not careful about this distinction and this Leibniz law? Some very strange paradoxes and problems can arise. So again, the idea is that the kind of thing that an object is and the identity condition that it provides is crucial to understand the relation that exists between different objects. And there's this a famous problem, the problem of the Tibble's cat, the problem of 1001 cat by Peter Geach. So Geach, he produces this problem. He says, suppose that you have this cat, Tibble's, it's a famous cat. Let's suppose that cat is sitting on the mat. And then Geach says, now let's see, and I'm going to just quote, now let's see be the largest continuous mass of feline tissue on the mat. So in the same sense that we talked about the lump of clay, now let's talk about this lump of feline tissue. You know, there's a biological entity there, so there's this mass of tissue over there on the mat. And let's call that the whole thing C. And also let's suppose that the cat has more than 1,000 hair, which is usually the case. Then for any of our 1,000 cat hairs, say Hn, name each one of those hairs at H, H1, H2 until H1000, there is a proper part Cn of C, which contains precisely all of C except the hair Hn. So he says, let's define Cn as the whole thing C minus one of the hairs, the hair Hn. Let's call that Cn. We can define that, right? And every such part, Cn, differs in a describable way both from any other such part, say Cm, and from C as a whole. Of course, because each one of them has a different hair. One of them has a hair that the other one does not have. And again, by Leibniz law, they cannot be identical to each other. We're talking about different lumps of feline tissue. Cn, C1, C2, C1000, and C. They're all different from each other. Moreover, fuzzy as the concept cat may be, it is clear that not only is C a cat, but also any part Cn is a cat. Why? Because Cn would clearly be a cat where the hair Hn plucked out. And we cannot reasonably suppose that plucking out a hair generates a cat. So Cn must already have been a cat. He says, you have C, you have the Tibbles sitting there, right? Imagine that you pluck out one of the hairs, like H10. You pluck out that H10. Now you still have a cat, right? It's not like that when you pluck out that hair, you suddenly have the previous cat dies and now you have a new cat. It's still the same cat. However, C is no longer there. C is gone. And what remains there after you pluck out HN is CN. So he says it's clear that not only is C a cat, but also any part CN is a cat. But now we face a problem, because if any of CN is a cat and you got C there before you pluck out, you have C there and you have 1,000 CN as parts of that C, and each one of them is a cat. Why? Because as we said, if you pluck out for any of those CNs, what remains would be the same cat. So Geach concludes that, so contrary to our story, there was not just one cat called Tibbles sitting on the mat. There were at least 1,001 sitting there. Right? So C1 to C1000, they're all different from each other, but it seems that they're all the same cat. Or not the same cat, there are a cat. They all can claim that we are the cat. If C is the cat, you pluck out HN, what remains is CN, and we would still say it's the same cat. I don't have a new cat when I pluck out a hair. So what's going on here? Now the solution that Geach proposes, which we don't agree, and then we will see how we can solve it in a much better way. Geach says everything falls into place if we realize that the number of cats on the mat is the number of different cats on the mat. Of course, that's how we count, right? And C13 and C279 and C are not three different cats. They're one and the same cat. Though none of these 1,001 lumps of feline tissue is the same lump of feline tissue as another, each of them is the same cat as any other. Each of them then is a cat, but there is only one cat on the mat, and our original story stands. So Geach says it's true that C13, C279, C, they're all different from each other. They're different mass of tissue. But Geach says we have to say that they're all the same cat. Each one of them is a cat. And even though C's are different from each other, but they're all the same cat. But of course, Geach realizes that there's a price to pay here. Why? Because based on the Leibniz law, we have C1 and C10, for instance, and they're different from each other. But at the same time, you want to say that they're the same as each other. But Leibniz says if they're different, then they're different. If there's something true of this one, then not true of the other one, that you cannot say that they're the same. So that's why Geach says the price to pay is that we must regard something is the same cat as something as expressing only a certain equivalence relation, not an absolute identity restricted to cats. So Geach says, of course, if you're thinking about, if you say that C1 is a cat, C10 is a cat, and C1 is not identical to C10, then if you're talking about absolute identity, then Leibniz law tells us that we have to say that this cat is different from that cat, and therefore we have two cats. But he says no, that would lead to this problem. So let's say that it's true that these feline masses of tissue, they're different, but we can put all of them into a class, into an equivalent class of the same cat. We can create this kind of relation, which would be like symmetric and reflexive and transitive. So it will create a partition, and it will create these equivalence classes that you would say that C1 and C10, they're in the same class of Tibbles the cat. But the two things about this response, one is that the price that we are paying here is actually much higher than Geach is proposing here. And the other thing is that there is actually a much easier solution. So if we have understood the concept of the statue and the lump of clay and how they're not identical with each other, we can easily see where Geach has gone wrong here. So first of all, the price that we are paying, the relative identity that Geach is talking about, in a sense that even though C1 and C10 are not the same lump of feline tissue, yet they are the same cat. That means a relative identity. They're not identical as a lump of feline tissue, but they are identical as a cat. That's relative identity. But this leads to relative existence, which is a very shady concept in metaphysics. Relative existence means this. Suppose we say that C is the same cat as Cn. That's what Geach is proposing. Now, plucking the hair Hn destroys C. And Cn is a cat. Right? So we have the C, which is the same cat as Cn. When we pluck out Hn, we destroy this lump of feline tissue C. But Cn is still a cat. Therefore, C remains to exist as a cat because it's the same cat as Cn, and Cn exists and Cn is a cat, and C is the same cat. So C exists as a cat, but not as a lump of feline tissue. And that's relative existence. That we say that something can exist as A, but not as B. And you can see why this is shady, because that can lead to very strange results. Like imagine you have a statue and then you press it down. Then you can say, oh, the Albert Einstein statue, that doesn't exist as a statue, but it still exists as a lump of clay, which is strange. How are we going to count this kind of relative existence? If I ask you how many things are there like the lump of clay and the Albert Einstein statue as a lump of clay there? Or do we have like one thing, which would mean that any lump of clay that you encounter, it might be that lump of clay that you see, it might be a statue that is not existing as a statue, but existing as a lump of clay. But that's just completely weird to say that something can exist as something, but not as another thing. But we don't need to go there. There's actually a much easier way out of this problem. If you go back to Geach, what he says, there's a problem here, where he says, it is clear that not only is C a cat. And the question is, what do we mean by that? C is a cat. What kind of is are we talking about here? If by is we mean the identity, what we're saying is C is identical to the cat, then that's the same mistake if we say that the lump of clay is identical to the statue, because the lump of feline tissue is in a similar relation to the tibbles as the lump of clay is to the statue. And as we showed, the statue and the lump of clay are not identical to each other. So in the same sense, the lump of feline tissue is not identical to the tibble. So if we say that is of identity, that's wrong. The correct is that we need to say that C is a cat, is a C of constitution. And that's again another formal ontological relation that I'm introducing here in addition to identity. And that's the relation between the lump of clay, for example, and the statue. The lump of clay is constituting the statue, and C, as a mass of feline tissue, is also constituting the tibbles. So sometimes we do say that something is something else, but if you mean identity, that's wrong. But if you mean constitution, then that's correct. C does constitute tibbles. However, if we make this correction that is a constitution, we don't get into any problem. Why? Because when C constitutes tibbles, when we haven't plucked out any hair, no other Cn is constituting tibbles. So if C is a cat, then no other C is a cat, because none of them constitutes tibbles. It's C that's constituting tibbles right now. If I pluck out the hair, for instance, HM, C goes out of existence, and now CM is a cat. And is, again, we mean is of constitution. So there's always only one cat, Tibbles, and only one mass of feline tissue constituting Tibbles. The proper parts of that feline mass that's constituting Tibbles, again, does not constitute Tibbles. It's the C that's constituting Tibbles. So in general, now we see if we also add the ontological relation of instantiation, which is another formal ontological relation, now we have encountered three different is that we can use. One is the identity is, when we say that Tibbles is the cat on the mat. We say that cat Tibbles is the cat on the mat. Is that we're talking about the same cat. They're identical to each other. There's also the is of constitution, when we say that feline tissue C is Tibbles. What we basically mean that it is constituting Tibbles. And there's also the instantiation between the object and the kind, when we say that Tibbles is a cat. That's also an ontological relation between the particular Tibbles and the universal cat. Okay. So that's the object, and through these examples we were trying to show that identity condition seems to be crucial. To understand objects, identity condition is very important. And that identity condition comes from the kind of thing that object is. Now, what are the objects that we're talking about? Well, we'll see. The cat, the chair, you, me, an atom, the sky. Most of the things that we see around us are objects. Well, actually, everything that we see will be particular things that we see. And as we saw, particular things that we see, they fall only into two categories. They're either objects or tropes, as we will get into them right now. So this is one big category of the things that we see, and they are objects. The next particular thing that we see around us is what we call a trope or a mode. Remember what were tropes? Tropes were things that are born by objects. So objects can be in different modes. So for instance, you have a leaf as an object, and it can be green. That's a mode that leaf has. Or it can be yellow. That is a different mode. You have a chair, it can be red, or it can be yellow, it can be green. These are different modes. If you have a ball, it might be a sphere, but when you shoot it, it might change its shape, come into a different shape. That's a different mode. So the question now is, or at least the claim here is, that tropes are not objects, right? Because we are saying we have two categories for particulars. One of them is the object, and the other one is tropes. So we are implicitly assuming or claiming that tropes are not objects. And we define objects as those things that have a determinate identity condition. So what we are claiming here is that tropes do not have a determinate identity condition. And now we need to defend that claim. And the way that we would do that is the same thing, the same way that we motivated the idea of identity condition. How did we do that? We started by counting, right? So it's the same thing here. So we look at this image that we have, more specifically the crystal ball and the lump of crystal that is constituting that crystal ball. We have these two objects. Now that's something that I'm assuming that now we understand, right? We have this crystal ball, and then we have also the lump of crystal, which is not identical to the crystal ball, but it is constituting the crystal ball. So these are the two objects that we have, these two particular objects that we have. But we also have a trope here. These two objects have, of course, they have more than one. For instance, they're also black. But there's one that I want to focus now is the trope sphericity. So both are spheres, right? So they are both in this mode of being a sphere or sphericity. So now the question is, how many sphericity are here? So we're trying to count the number of modes sphericity here. Now we have two objects, both of them are spheres. So, I mean, the immediate answers, it might be that we have one sphericity or two, which two would make more sense if you have two objects and both of them are spheres in the mode of a spheres, and we're also assuming that trope is actually a particular thing. I mean, we can have arguments over that as well, because there might be some nominalists who say, well, trope, the mode of a thing, is not really a thing on its own, it's not a particular thing. But we're going with trope theorists here, that we're assuming that these are actually particular things. The more interesting question is, are they objects? So let's suppose that it's two. Let's suppose that someone claims that we have two sphericities here. But then we get into a problem. Because the sphericity of the lump of crystal and the crystal ball, they're both occupying the same space. They are exactly on the same space. They're overlapping each other. And they're also from the same kind. They both are based on the sphericity. So they both are sphericity from the same kind. So how can we distinguish them from each other? You're saying that there are two, but how can you say that there are two? When you say there are two, it means that there's a way that you can distinguish them from each other. But if they are occupying exactly the same space, so it means that if you look as close as you want to the thing, you cannot distinguish them from each other. It's the same thing. It's the same sphericity. They're exactly overlapping each other. And they also have the same kind of... They are from the same kind, which means that they have the same persistent condition. Why is that important? Because someone might say, okay, the crystal ball and the lump of crystal ball, they also occupy exactly the same space. When I look at this thing, it's not like if I look close enough, I can see, okay, here is the lump of crystal, and then here, over here is the crystal ball. No, they're also occupying exactly the same space. But the only reason that we could distinguish them from each other was through their identity condition, more specifically their persistent conditions. So even though they are exactly on top of each other, they're overlapping each other, when they go through those changes, their trajectories differ. One of them goes out of existence, the other one stays in the existence, and that's how we can distinguish them from each other. But these two tropes, these sphericities that we are claiming they're two, they're exactly on the same spot, they're exactly occupying the same space, and they have the exact persistent condition. It means that whatever happens to one of them, it will happen to the other one. But if they're occupying the same space and anything happens to the other one also happens to the other one, then how can we ever claim that we have two? Like how do we know that they're not more there? Because remember, for books, we could easily say that. Like if you put one book in front of someone and then they say, okay, this is one book, two book, three book, four book, we say, hey, wait a minute, that doesn't make any sense. We cannot have two books overlapping each other. Why? Because of the identity condition of books. We cannot have two exact material thing books on the same spot, overlapping each other. Because then we wouldn't be able to distinguish them from each other. How can I claim that there are not like hundreds of books there if two can be there overlapping each other? So it seems that it's not justified to say that we have two. And if we say we have two, then we open the door for God knows what. Someone comes along and says, okay, I'm going to say 1,000. Can you provide any kind of evidence that there are two and not 1,000? And there doesn't seem to be any. So we might want to get smart there and don't open that door from 2, 3 upward. Just say, oh, we have one. There's this crystal ball, there's this lump of crystal, but they both have one mode. They're both spheres. There's just one sphericity there. But we also get into trouble here. Because let's suppose that we create a very small hole inside the crystal ball. If you create a very small ball inside the crystal ball, what happens is that the lump of crystal goes out of existence because it will be a new lump. So the crystal ball and its sphericity remain unchanged, right? So if you remove a very small hole, you will still have that sphere crystal ball. Nothing changes. But the lump of crystal, call it C, is gone and replaced by a new lump C prime, correct? However, even though C does not exist because we remove the hole, the sphericity of C still exists. Why? Because the crystal ball exists and they had one and the same sphericity. So we had this crystal ball and then we had a lump of crystal, and we are claiming that they were sharing this one sphericity. Now I remove a small hole. By removing that, I completely destroyed the lump of crystal, but its sphericity remains there. But this is strange because this means that the sphericity of an object or a mode of an object can exist without that object existing. The sphericity of that crystal, that lump of crystal, remains without that lump of crystal existing. So the question is, if that's possible, why have we never seen them detached? Because remember, that's the way that we suggested the concept of trope, that these are the things that objects have, like they bear these tropes, and tropes always need this kind of object to exist basically on top of them. They cannot just exist independently of that object. We'll never see, for instance, the sphericity of a ball just floating around without the ball. We never see the redness of a chair without the chair itself. We never see the shape of a statue without the statue. We never see the blackness of something without that thing that is black. We always see objects that are in different modes. We never see modes pure without any object. But if we are claiming that there's only one sphericity, this means that the sphericity can exist without the object. And the idea is that not only does that sound weird, and it does sound weird because we've never seen anything like that. Anything that we see, everywhere that we look, we see particulars in different modes. And that's a good practice. Just look around at everything that you see. You will see objects in different modes. You will see objects in a specific position with a specific velocity, in a specific orientation, in a specific shape and color and taste and sound and specific relations to each other. You will never see a mode on its own out there. So that brings the explanation of particulars to an end. So we have objects and we have tropes, and as we said, objects, we define those things that have a determinate, particulars that have a determinate identity condition, and we said tropes, they don't really have a fully identity condition. If even we assign some kind of identity to them, it's always through the object. So we can never ever talk about the blackness of this crystal ball without identifying the crystal ball. The identity of that sphericity is basically it's borrowing its identity from that crystal ball. So they never have this kind of fully identity condition. So we cannot really count them. So yeah, that's the particular part. In the next video, we will go to universals. Now for the universals, it will be a little bit longer because we need to first justify the the existence of universals, of kinds and properties. For objects and tropes, that's less controversial because, I mean, there's almost no one who can claim that there is nothing existing, no particular things exist. Particulars, we can see them, it's everywhere, we're fine with it. So for the existence of particulars, we didn't have to motivate that much. But for the existence of universals, we do need to motivate, because there are philosophers who claim that universals cannot exist, namely nominalists. But that's something for the next lecture.